These are the notes for Algebra 2, Section 7.4, Part 2. We're continuing evaluating logarithms, and today we're going to specifically be looking at inverses of logarithms. Now, there are a couple of inverse properties that we're going to be using pretty heavily in this section and after this section. The first inverse property says that if I have log base b of b to the x power, that equals x. In other words, the log base b of b cancels itself out, and we're left with x. So for instance, if I had log base 3 of 3 to the second power, that would equal 2, because log base 3 of 3 cancels out, leaving me with just 2. The second property is if I have b raised to the log base b of x power, right? So log base b of x is entirely in the exponent, then that also equals x. This b to the log base b cancels out, and we're left with just x. So if I had 3 to the log base 3 of 2 power, then that would also equal 2. Right? This exponent is the only thing that's left over. So that's the basic idea, and we're going to see how we can use that to evaluate exponents, or logarithms and exponents. Here we go. We want to start simplifying the expression. I have 10 to the log of 6.7. Now, of course, this is log without a number, which means this is the common log. So it already has a log base 10. So 10 to the log base 10 of 6.7, the 10 and the common log cancel each other out, and we are left with 6.7. So that is the value. Here I have log base 2 of 16 to the x. Now this is a little different. In this case, we actually want to go about this a slightly different way because we don't see immediately that we're repeating b in this case. Instead, we want to take this 16 and we want to rewrite it so that it has a base of 2. And in this case, 16 equals 2 to the 4th power. Right? 2 to the 4th power is 16. So I'm going to rewrite this log base 2 of 2 to the 4x. The reason why it's 4x is because of the power of a power property, which says that if I have 2 to the 4th raised to the x power, I have 2 to the 4x. Now, as you can see, I do have log base 2 of 2, which of course will cancel itself out, leaving me just with 4x. And that's my answer. The next thing we might be asked to do is find the inverse of a function. Now, finding the inverse of a logarithmic or exponential function is similar to finding the inverse of any other function in that the first thing we have to do is switch x and y. Right? That's the main thing we do. They're a little bit easier, I think, because once you've switched x and y, most of the work is just converting from logarithmic to exponential form like we did in part 1, or from exponential to logarithmic form, again, like we did in part 1. So these are usually easier than they look. For instance, if I wanted to find the inverse of this function, y equals log of 3 halves, log base 3 over 2 of x, y equals log base 3 over 2 of x. The first thing that I would need to do is switch x and y. So I have x equals log base 3 over 2 of y. And then I simply convert from logarithmic form to exponential form. The base is 3 over 2. So that's my base. The exponent would be x, and it would equal y. That is that exponential form that we saw in part 1, where we have b to the x equals y. Alright, this one, the next one, part 2 here, is going to require a couple more steps, but not by too much. We're still going to start out exactly the same way. We are going to swap x and y. So we get x equals the natural log of y minus 4. Now notice that y minus 4 is in parentheses. That's telling me that we are taking the natural log of this entire expression. Our next step, just like before, is to convert from the natural log form to exponential form. And we do it basically the same way. Since this is the natural log, our base is e. So we're going to start with e to the x, which is our exponent, equals y minus 4. That's what it equals. Easy enough. Now we just need to get y by itself, because remember, we have to solve for y. So we add 4 to both sides, and we get e to the x plus, let me rewrite that, make that a little bit prettier. E to the x plus 4 equals y. That is our inverse. Now, these inverses are going to be pretty useful, and this technique is going to be pretty useful when we get to solving logarithmic and exponential equations. For now, we're just going to be finding inverses, and we're just going to be using the inverse properties to evaluate expressions.